Yes, so we created here an interface called I3D. All interfaces, they have to start with the keyword I. It's a convention, not mandatory, but you can start with I, followed by 3D. So in this, we have two method declarations. One is volume, other one is surface area. There is no definition, just only declaration. Okay, if you know about the C language, you have header files, .h. There you find only prototype of the function. Prototype meaning is here how you need to call the function, those details you have in that. So when we talk about volume here, volume is going to return here double type of data, and this does not require any parameters. Similarly, surface area, if you take, so this doesn't require any parameters here, it returns double type of data. These two are incomplete here. Okay, we haven't supplied code. In the interface, just we declare the methods, but for them we need to supply the code where I mean, whatever class is implementing the interface. If you look at the cube, cube is inheriting square class and it is implementing I3D interface. Okay, square is actually inherited into cube class. Then when you talk about actually I3D, so I3D interface is actually here implemented by the cube class. What does it mean here? It means we need to implement here the two methods, volume and surface area in the case of the cube. And apart from that, here extra what we require, volume and surface area, that is enough. We don't require any other thing. Whenever you take cube, okay, because it is nothing but square. The base of the cube is nothing but square. Extra you have a side. Extra side we have, that is nothing but height. So we don't require any special property or special state called height, because the side is equal in width, in length, and in the height. All the three are going to be equal in the case of cube. Okay, so therefore we don't require a separate method or separate state for the height. Whatever side we have in the square, that is going to be inherited into this cube class here. Okay, square is getting inherited into cube. That means whatever functionality we have with the square, that is available here. Along with that, it is going to implement here two different methods of the interface I3D. Okay, so where we have implemented, we implemented here public double volume, return side multiplied with side multiplied with side. It is nothing but volume of the cube. And as far as surface area is concerned, 6 multiplied with the area. Okay, or else here what you can write, you can just go with this and you can type the area here. Area multiplied with side is going to give you the volume. Okay, so like this, we have defined here two more methods called volume and surface area. And here we are using entire square in the cube class. Okay, but extra methods, what we need in this, we need here the volume and surface area. The state is same. Okay, if you take side of the square, the same thing we use in the cube, because whenever you go with the cube, cube is three-dimensional, extra height we have. So height also, it is going to be like whatever I mean units you have in the side, same units are actually with the height also. Okay, so side is only same side, both with the width, with the length, and with the height, same side value we take. So therefore, here with the help of the volume, here we with the volume method, we find the volume. Similarly, using surface area method, we get the surface area. Then here we have a toString method. With the help of that, we are printing here x coordinate, y coordinate, side, area, perimeter, volume, and surface area. Like this is working for us. Okay, so we have overridden, I mean, toString method, and we have implemented here the volume and surface area. Okay, we have implemented here surface area as well as volume. Then we are inheriting square into this particular cube. So this is called as here inheritance. We call this as inheritance, and I3D is nothing but here interface. So where have we defined here interface here? Public interface I3D, the double volume, double surface area. We have written like this. Okay. So now let us come to the program.cs here. So I don't want to implement, I don't want to run here anything. Rather, I want to implement here some other code. Okay, I want to create here some kind of classes here itself. So what I write here, I can go with the square class followed by object square equal to here new square. When you go with the new square, there are two versions of the square class. Okay. We take here IATX, IATY and side. Okay, we have here IATX, IATY and side we have. So let us give here something like 10, then 20, followed by side is 10. Like this, you can create here a square object. Then write console dot write line. Then here we try to print object as the dot to string. So using this, we can here print the data as well as whatever are possible with the square. That means we get x coordinate, we get y coordinate, we get side, we get here area, we get here like perimeter, all the things we get with the help of this. Let us try to run this here. Okay, this is exiting. Application is being exited here. Application actually exiting here in this case. Okay, single apartment thread. This is, I don't want to go even with this one. Just try to run this here. What we get, let us once again try to run this. Basically, here we need to use it for creating a Windows application. Even this part also I try to comment. I do not want to go with the STA thread. Then try to run again this here. Okay, it's not working. It is just exiting. Fine, no issue. Okay, then here, let me remove this here. It is going to launch that particular thing. Okay, but here I want to create a new class. I would like to go here with a new class add followed by new item. I just want to define a class. Okay. Oops. The class name is here. Oops. I would like to add. And I want to make this as here public. Inside this, I would like to write here main method. Public, then followed by static, then void. Go with the main method here. Okay, string. Here this is args. Okay, we try to write this particular thing here. Now go to the project. In the project properties, we can name this as here console application. Okay, we can name this as console application. And what is the startup object here? You need to go here with the startup object. With oops, we are going to be starting this. And we can change this to 8.0. Okay, now let us try to run. In that case, this can work for us. Now I don't want to run this. I want to go here with the oops.css, CS. So with this, I would like to run this. So what I do here now, I'll go with the square class. Right here, object s equal to here, new square. I can go with the default constructor or I can go with the parameterized constructor here. So let me go here with the default constructor. I put here 10 followed by 12, then followed by some 8 we put. Site is going to be 8 for us. Now console dot write line. So here let me write object s, then followed by here dot toString because we have overridden this. Okay, now run this and what result we get, see in this. It is printing for us x1 10, x2 12, then side equal to 8, area equal to 64, perimeter equal to 32, it's giving. It is not x1, x2, x1, y1 this is. So we need to change the code in that. Where did we define here? Here we defined. Okay. So when it comes to here, the square, it is not basically x1, x2, it is actually x1 and y1. We need to write this as x1 and y1. Accordingly, it has to print for us. Similarly, when you go with the cube, same thing, it must be here. It is not x2, it should be here y1. Like this, we need to go. That is nothing but here, center point or starting point of the application. Okay, start running it. Now we get it as x1 10, y1 12, side is 8, area is 64, perimeter how much? 32 we got. So this way, here what is happening? It is printing for us the x1 coordinate, y1 coordinate, area as well as perimeter. They are all getting printed. Okay, we created here a square object. Here we created a square object. Now let us go here with the cube object and see. Cube, okay, this is here object C equal to, here it is new cube. We don't have any constructor here, so default constructor we take, but here in this case we write object C dot, we can go here with the x value, x equal to put some 10. Okay, object C, then dot y equal to, here go with the 10, followed by object C, then here this must be a side. We need to go here with the side. Side equal to, go with some 25. Now what happens here, you need to get the surface area as well as volume. So just go with the console dot write line. Okay, we have kept all that code in the toString method. Object C, the dot toString. With that, we can find all that information. So it should print x1 equal to 10, y1 equal to 10. Then the side equal to 25. Area must be how much? 625. Then perimeter, how much you need to get? You need to get perimeter as here. Like perimeter, how much you need to get? 100 you have to get perimeter. And the volume must be how much here? 625 multiplied with 25. Whatever value we get, we are going to get it as actually volume. And surface area is going to be here 6 into 100. 6 into how much it is? 625. So 6 into 625, whatever value you get, 6. So how much you get? 3600, 3750 you have to get surface area. Just run and see what do we get in this. Okay, x1 10, y1 10, side is 25, area 625, perimeter 100, volume is how much? 15,625, and surface area how much we got? 3750 units. Automatically it's creating for us whatever are required in that. Okay, So it is getting here with the help of the toString method. With toString method, we are printing all the things here. So here we created a square object as well as circle object. Okay, now let us see here a concept called upcasting and downcasting. In the earlier, whenever you take the data, you have seen narrowing conversion, similarly widening conversion. In the same manner, here we try to see what is upcasting and what is downcasting. When you look at the square and circle, sorry, square and cube, square is the base class. Similarly, the cube is what here? It is a subclass. Square is parent class and cube is child class. Okay, now here I want to create an object like this square. Okay, object s equal to, sorry, object equal to, I just write new followed by here cube. I can create here a reference variable square object I am creating, but that is referring actually cube. So in such cases, it's going to be working like a square only. It will not be behaving like cube. Because whatever are defined in the cube, you can whatever you defined in the square, they are available. So this feature is called as upcasting. Okay, this feature is called as here upcasting. What I do here, square object equal to new cube I am writing. Okay, so reference variable is what type here? Square type. With this we can create a cube object. But what happens in such cases? You can access only the whatever features you have in the square class, you can access them. You cannot access the features of the cube class here. You cannot access the features of the cube class in this. Let us try to see here. Object dot. Okay, let us try to print here. Console dot right line. Here just we go with this type here object dot toString. So with this, what gets printed? Let us see in this. Start debugging, and what do you get? See in this. X110, Y10, side equal to 1, area equal to 1, perimeter is 4, volume equal to 1, surface area 6 we are getting. We are not getting here volume or anything. Because whatever features you have in the square, you can access them, even though you created here cube object. Let us go with this object dot x equal to, you can take some 5. Similarly, object dot y equal to, here you can go with some 100. Then write here object dot side equal to, go with some 35. Okay. So here what happens? Even though you said these things, when you go with the object dot toString, what happens in this case? Whatever features available in the square, you can access them. Reference variable is what type here? The square reference variable, but you are creating an object which is actually cube object. Though you created cube object, only the features of the square you can access from the cube object here. The object whatever created is cube, that is fine, but in the square class, whatever features you have, you can access only those from the cube object. Whatever cube features you have, you can't access. So this feature is called as here upcasting. A child class object can be assigned to base class reference variable. Okay, but in that process, what happens? Whatever features available in the base class, you can access only them. You cannot access actually the child class features. All features you can't access. Okay, let us try to define something like this. What happens? See, I go here with a cube followed by x equal to, I try to write here new square. When I try to create like this, it will not accept. This gives error for us. Okay, it is going to give here error. So this is going to give here a problem for us. This feature is called as here downcasting. This feature is called as here downcasting. That means a parent class object you are trying to assign to a child class reference variable. Okay, a parent class object you are assigning to child class variable. This is not accepted. Because when you go with the cube, you have so many methods, so many other methods when compared with the square class. Because in the cube you have a volume, you have surface area. Okay, they are not part of square. If you try to create a reference variable with the base child class, and if you create a base class object, and if you try to refer the reference variable of the child class with the base class object, then in that case it gives error. Because if you try to use the cube here, in the cube you have volume and you have the surface area, which you can't find in the square class. So therefore writing like this is wrong. It is something similar to narrowing conversion. In the widening conversion there is no problem, but in the narrowing conversion you have a problem. So this is not acceptable here. That's why it is giving error. So this feature is called as here, downcasting. In the downcasting, what you do exactly, you take the child class reference variable, okay, and using that reference variable, for that reference variable, you are trying to create here a base class object. Okay, when you create a base class object like that, it is in fact wrong, because in the child class you have more and more methods. Those methods you can't access, you don't have in the base class. Okay, the child class, you have volume method, you have surface area method. Those you don't have in the square class here. So therefore, if you try to access here, like surface area and other thing is what? Volume, since they are not part of square, so defining like that is wrong. So this is going to give error for us. So therefore, this is invalid, and this feature is called as here downcasting. We call this as downcasting. So the first one is called as here upcasting, and this is called as here downcasting, which is actually illegal if it's wrong. Okay, this feature is called as here downcasting, and this is called as here upcasting. Okay, so this is here upcasting. Upcasting meaning is what in this case? You can take a base class reference variable that can refer a child class object. Because whatever features you have in the base class, you can access them in the child class. So there is no problem in that case. But when it comes to here downcasting, what happens here in this case? You are creating a reference variable with the base child class. You are trying to access here a base class object. Okay, if you look at the reference variable of the child class, you find more features when compared with the base class. So therefore, it is illegal to downcast like this. You get error. So don't do like this. This is in fact wrong. Okay, so here using classes we have done. Now, what I do here, I can create a cube. I'm going to create here a cube, but there is no default construct, only we have in this. So using here now x dot x equal to, you can put some 20, then here x dot y equal to, put it some 15. Similarly, x dot side equal to, go here with some side 15 you put. We are making something like this. Okay, now we have an object called x, which is nothing but here cube type of class. It is nothing but here cube type of class. Okay, so next thing, what I can do here is I can create a interface reference variable. I can write here i3d. Okay, i3d, then here object 3d equal to, it is object 3d, this equal to, I can write this as x. Okay, I'm assigning here the x variable. X is nothing but it's a reference variable. What type of variable? That is cube reference variable. So x is accessing here cube object. Now what methods I can access from the object 3D now? I can access only volume and surface area. Other things I can't access. So let me go and print here console dot, here right line, then write object 3D, then dot here followed by, okay, if I go with the toString, what happens? See in this. Okay, what will happen in such cases? Let us try to print this. Okay, it is printing here area, perimeter, volume, and other thing is what surface area is getting printed. Okay, now similarly here object 3D followed by here dot. Then can I access anything like X in this? I can't access X. I can't access Y. I can't access here side. Okay, I can get only volume in this. Only volume I can access. Similarly, I can access here perimeter, the surface area. Other things I can't access in this. Okay, if I go here with the, like I try to type here area, is area available? Area is not available, only surface area is available for us. We can print only surface area. Okay, but if you go with the X, in the case of X, what are available for us? If you go with the X, side is available, area is available here, all these are available. What is happening exactly? So using cube reference variable, we created cube. Whatever features you have in the cube using X, you can access. But here what we are doing, I3D, object 3D. This is nothing but here interface reference variable equal to I am writing X. X is an object which is nothing but cube objects, no problem. But when you go with the object 3D, what are the features available in that? Only three things are available. ToString. Similarly, here next thing is what? You have area, not area, you have volume, and other thing is what? Surface area. Not even volume, not even perimeter. You can't get them. Because in the I3D, you have only just two methods declaration. If you go to circle.cs, and if you see here I3D, what are available in this volume and surface area, you can access only them. You cannot access actually all other things which are available with the cube. So like this, you can declare here interface reference variable, and whatever you want to access from interface, you can access them. So rest we don't require in such cases. This is going to be lightweight when compared with others. I3D object 3D equal to X. So what is happening in this case? We are assigning the cube object to object 3D. So from this, you can access only volume and surface area. And again, this is called as here UpCasting. You can think it as actually UpCasting. So here I3D is here what exactly? You can think it as a base class. So that we are implementing with the, which one? We are implementing with the cube. So therefore, whatever features you have in the cube, they are not available. Only here, whatever are defined in the I3D, you can access them. Volume and surface area, you can access. So like this, you can use them. So these features are called as upcasting and downcasting. Now let us try to create something like this here. Okay, I want to write I3D. Okay, followed by here object 3, something like this. I write here new followed by here. I go with the square. I cannot make something like this here. If I try to make something like this, this gives error. Why it is giving error here? Square is nowhere related to the I3D because square clause is not actually here implementing I3D. It's not implementing actually I3D, so therefore we can't create. There is no relation between the square and I3D here. Rather than that, what you can do, you can go here with the shape object here. Shape followed by here, write object as equal to here, you go with the new, then this is here square. Okay, you can create something like this here. I think object S is already defined here. Object S1 equal to new square. If you go here with the object S1, what are available for us? Let us see. Area is available, perimeter is available, version is available, get quadrant is available, but other things are not available. If you try to put X, it's not available here because they are not part of the, which class here it is? This is what class exactly? Shape class. In the shape class, we don't have them. If you come here and see the shape class, what are defined in this C? Okay, it is private method. It is a private method side. Okay, this is the square. But if you go with the shape class, if you come down to the shape, in the shape, what are defined? C. In the shape, we have like area, we have perimeter, then one more thing is here pi, this is a property method. One more thing is here version, and another one is here get quadrant. They are available for us. Okay, if you come down here, you can type pi, pi is available. Okay, you can go here and perimeter is available, area is available, version is available, get quadrant is available. But other things they are not available here, like X is not available, Y is not available, they are not available for us. Side is not available in the, if you go with the shape class. This is called as here again upcasting. Square is a child class object. This shape object, this one is what here? Base class object. Okay, using a base class reference variable, you can access a child class object. But in that process, what happens? Whatever features are available in the base class, you can access them. You can't access the features of the child class. So like this is called as here again upcasting. This is called as here upcasting. Vaishnavi, are you following this?
Yes, I'm following.
These are actually very important when you work with the object-oriented programming.
Okay.
So you need to understand these concepts, then that can be called as object-oriented programming. Now, if you
Yes.
have any questions, you can ask actually. Let us discuss more about those.
No, present at